Hey guys, so we are on notes 3.3, day 2. This is on the product rule. Okay, so it's another rule that you have that you're going to have to add to your tool belt to take a derivative, and it's pretty cool. Okay, so first of all, example 1, does the curve have any horizontal tangents? If so, where? What does it mean when they're asking us for horizontal tangents? Well, it just means that they want to know where is the slope 0? Oops, I didn't mean to put an apostrophe on the means. Means the slope is 0. So where is the slope going to be 0? Okay. Well, remember, slope has to do with taking a derivative. So we're going to need to first find the derivative. I can spell, guys. Find derivative. Oh my gosh. That's when you could tell it's a Monday. Can't get my brain to work. Find the derivative. So we're going to find y prime. Well, we can use the power rule on that. We just learned that, and I think you guys are getting good at it. It is 4x to the third minus 4x, and then the constant goes away. It's gone. Okay, so remember, the derivative is the slope. And right now, I don't know exactly what the slope is, but I have a slope formula for it. So for the next part, what I can do is I can set that formula that I just got equal to 0, because we know that we're looking for where the slope is 0. So that's the next step. Set it equal to 0. So 0 equals 4x cubed minus 4x. Okay, well, we've got to solve for x, and we've learned a couple ways to solve back in Math 3, okay? And we have a polynomial there, and what we can do to solve is factor it. Okay, all right, so I have 0 equals, well, the common factor that 4x cubed and negative 4x have is a 4x. And when you factor that out, divide it out, you'll have x squared minus 1 left in the parentheses. And then by the 0 product property, because both of these factors should equal 0, we can set them each equal to 0. So we'll get 4x equals 0. When we solve, we'll get x equals, sorry, not 4. 0 divided by anything is 0. I don't know why. Like I said, Monday, that's what I'm going to claim. And then when I solve for x here, I'm going to add 1. So I'll have x squared equals 1, but then I'm going to have to take a square root. So anytime I'm solving for x and I have to take a square root, it means that that x could have been a positive 1 or a negative 1, so plus or minus 1. So I have 2 solutions here, 1 solution here, for a total of 3 solutions. Okay, remember, we're supposed to say where. So I have the x values. Now I need to find the y values that go with these x values. That leads me to the next step, where we gotta get the y values. Okay, so far I have an x value of 0. I just need to find the y value that goes with it. I have an x value of positive 1. Need to find the y value that goes with it. And an x value of negative 1. Gotta find the y value that goes with it. Okay, well, let's find that y value. So what I have to do is I have to take it to the original. So go to original equation. Okay, and the original equation was the y equals x to the 4th minus 2x squared plus 2, and plug in that 0. So y equals 0 to the 4th minus 2 times 0 squared plus 2. Well, that goes to 0, that goes to 0, so the y value is a 2. So I have a 0, 2. For the next one, do the same thing, but plug in a 1 now. So y equals 1 to the 4th minus 2 times 1 squared plus 2. So that will be 1 minus 2 plus 2. Well, the negative 2 and positive 2 are going to cancel each other out, so this is just going to equal 1. So when x is 1, y is 1. Okay, last one. All the same steps. This time plug in a negative 1. So we'll have negative 1 to the 4th minus 2 times negative 1 squared plus 2. A negative number to an even power will always be positive. So that's a positive 1 minus, so remember, or a negative number to an even power will always be positive. So that's positive 1. And 1 times negative 2 is negative 2. And again, the negative 2, positive 2 cancel out, so all that's left is a 1. So when x is negative 1, y is 1. Okay, so the answers are 0, 2, 1, 1, and negative 1, 1. This is where there's horizontal tangents, where the tangents have a slope of 0. Okay, letter B. F of x equals x squared, or you know what, we're going to skip this one. I think we get the idea. We'll go on to example 2. It says use the calculator to find any horizontal tangents for y equals 0.2x to the 4th minus 0.7x to the 3rd minus 2x squared plus 5x plus 4. So in our calculator, remember we learned this in the last lesson, we have to use the math and then 8 button. So math button and 8 button. Okay, and so here is the best way to do this. This is your notes, so let's write this down. So what we're going to do is we're going to put the derivative into y equals. And we type that in when we hit the graph button on our, or not the graph button, the y equals button on our calculator. Then we're going to hit graph, and we're going to see where it hits the x-axis. Because remember, that is where the slope is 0, because a derivative of 0 means that that is where the tangent line is a horizontal line, because the slope is 0. Derivatives mean slope. Okay, so that's what we're going to look for. All right, so I'm going to grab my calculator. Calculator. All right, and y equals, and I still have all this stuff that we did in it last time, so there we go. It's all fresh. All right, so we're going to take the derivative, so I have to hit math 8 d dx of 0.2 x to the 4th minus 0.7 x to the 3rd minus 2 x squared plus 5x plus 4. Oh, I put an extra parentheses. Oh, shoot, it cleared the whole thing. Gosh darn. I wasn't sure what to push. 0.2, sorry, x to the 4th. Bear with me, guys. I know. X to the 3rd. I'm gonna plead the Monday. Plead the Monday. Plus 5x. Oh my gosh, what's wrong with me today? 2x squared plus 5x plus 4. And now I need to go back and make sure that 0.2x to the 4th minus 0.7x to the 3rd minus 2x squared minus 4. Okay, I think I typed it in right now, but I gotta check. And since we're not looking at a specific point, we're gonna put x equals x. Okay, and then we're gonna hit graph. I was like, what's taking so long? There it goes. It's just running a little bit slow today. Oh, it's coming back up. So it's going to hit the x-axis again. So I need to change my window. I think what I'm going to do is go to window and I'm going to change it to this. It's not standard. Standard is -10 to +10, -10 to +10. Okay, so go back to the graph. And it's thinking. My calculator's running slow today. And my throat, my voice sounds weird. I feel like, oh, there it goes. There is a lot of smoke still in the sky. I don't know if you guys saw the sunrise this morning, but the sun was orange again. So you know that there's a ton of smoke in the sky. All right, so there's going to be 3 points here because this is the derivative, right? 3 points where the graph crosses or touches the x-axis. So I'm going to hit trace, and I want to find where the y is 0. And this is approximately one of them. So 0.909, it looks like. I wrote 9.8 on mine, but I think that's because I thought the 0 was an 8. But it's 0.909, so let's write that down. So we have positive 0.909, comma, and the y value comes from the original equation, so we're gonna have to plug that in just like we did up here. So we'll have to wait on that one. And then let's see, let's go to the next. Just hitting the arrow. Oops, went too far. Okay, can't get exact in there. Okay, so 3.48. Yeah, 3.48 approximately. Everyone's calculator might be a little bit different too, the way it's rounded or how it's zoomed in. Let me zoom in because I feel like I'm kind of below. Yeah, it says -0.5. So let me see if I could zoom in. Oh, geez. Zoomed in too much. It should be coming back up. Someday, there it is. I'm like, I'm not lying. It's just my calculator's slow today. Oh, there it is. Okay. I was like, I'm hitting it. Yeah, that's as close as I can get. 3.56 or 3.52. So I'm going to go with the 3.52. That one looks a little bit closer. So 3.523 if I round it properly, and then we'll have to find the y value it goes with. And then the last one, let me change my window back to normal. -10, +10. Yeah, sometimes we have to mess with the windows a little bit to get what we need from the graph. And then it's gonna take forever to graph it. I wonder if I just need to clear the memory real quick. But that won't be real quick because I don't know how to do that. I mean, I do, but it takes me a while. All right, so now I need that last point right there. So I'm gonna hit trace. There it is. And -1.74. No, that one's more exact. Yeah, right there, it looks about right. Looks to be centered. It's not going to be exact because we're kind of estimating here, but we can get pretty darn close. All right, so we have to find these y values, and let's put in our notes that these y values come from the original equation. Okay, so that means we're going to have to plug them into the original equation to find the correct y values that go here. So what's beautiful is that our graphing calculator can pretty much do this all in one whack. So let's see how it goes. And always double check it. And when in doubt, use those parentheses. Okay, so I'm going to have 0.2 parentheses, and the x is 0.909. Whoops, 909 to the 4th power. Okay, and then you have to arrow down. And then it goes minus 0.7 times x to the third. So 0.909 to the third. Arrow down. And then minus 2 times 0.909 squared. When you hit the squared button, it's nice. It already brings the cursor down for you, so you don't have to arrow down. But for all the other ones, you have to arrow down. And then plus 5 times 0.909. And then plus 4. And this is what I'm getting, 6.503. Okay, now do the same thing, but plug in 3.523. I wonder if, nope, it doesn't let me scroll and change it. Well, it was a good idea. Okay, I'm done. Stop it. Okay, there we go. I was like, why isn't it clearing? All right, 3.523. Sorry, I'm a mess today, guys. What was it again? 3.523. To the fourth. I was like, where's the button? Minus 0.7 times 3.523 to the third. Minus 2 times 3.523 squared. Plus 5 times 3.523. Plus, it was 4, right? Yeah, plus 4. And I get negative 3.007. And then the last one, okay, so 0.2 times negative 1.818. There's negative 1, yeah, 1.818 to the fourth. Minus 0.7, negative 1.818 to the third, minus 2 times negative 1.818 squared, plus 5 times negative 1.818 plus 4 equals negative 5.309. Okay, and then here's finding the horizontal tangents using our calculator. Honestly, I think it might be faster to do it this way, but when you're dealing with decimals, you know it's not going to factor pretty, so these ones, it's just best to use a calculator. That would be a calculator problem, okay? All right, example 3. It says find the equation of the tangent line to the curve given at the indicated point. Find the normal line at the indicated point. Use your graphing calculator to verify your results. All right, so first of all, we need to find the tangent line. So we need to find the slope, obviously. So we have to take a derivative. So y prime, so this would be 5x to the fourth. Gotta love that power rule. Negative 2 times 3 is negative 6, x squared plus 7. Okay. And now we could plug in the x value so we could find what the slope is at that point. So let's write it this way. We'll kind of merge function notation with regular notation. We're plugging in the 1 into the derivative function. So we'll have 5 times 1 to the fourth minus 6 times 1 squared plus 7. So that equals 5 minus 6 plus 7. 5 minus 6 is negative 1. Negative 1 plus 7 is 6. So there's our slope. So now we have enough information to write the equation of the tangent line. So t of x equals, so the slope is 6 times the quantity x. The point is minus 1. And then the y value is a positive 6. Okay? And then we have to clean it up, distribute. So we'll get 6x minus 6 plus 6. Well, these 6's cancel. So I just have that t of x equals 6x. I feel like I have a lisp when I say the number 6. and it bothers me. So anyways, all right, so this is our tangent line. I'm just going to label it. I like to be organized. Don't know where the S came from. It's just one line. All right, so we've got the tangent line. Now let's work on the normal line. So n of x. Now n of x uses the slope of 6, but remember the normal line is perpendicular to the tangent line, so we need the opposite reciprocal of 6. The opposite of a positive 6 is negative, and the reciprocal of 6 is 1 over 6. And then we use the same point, so x minus 1 plus 6. And we clean it up. Negative 1/6 x plus 1/6 plus 6. Instead of 6, let's get a common denominator. So that would be 36 over 6. So this would be n of x equals 1/6 x plus 37 over 6. And here is our normal line. Okay. Now what we got to do is we have to use our graphing calculator to verify the results. So what does that mean? We need to put all 3 equations into our graphing calculator. So we'll have y1 equals the original, x to the 5th minus 2x cubed plus 7x. And then y2 is 6x, that's the tangent line. And then y3 is the normal line, the negative 1/6 x plus 37 over 6. All right, so let's put those into our calculator. So y equals, we'll clear that one out. So y1 is x to the 5th minus 2x to the 3rd plus 7x. Okay, y2 is just 6x. y3, now because that is a fraction, the negative 1/6, I want to make sure that it does it properly. So I'm putting that in parentheses, and then I'm hitting x, and then plus, I'm going to do the same thing, 37 over 6 in parentheses. Just because I know sometimes we have to tell the calculator very specifically what we are doing. All right, I'm going to hit graph. There's the first one. Here's the second one. And there's the third one. Let's zoom in, see what it looks like. There's the tangent line. And the normal line must be up above because I zoomed in. I hit zoom out. Yeah. It's kind of hard to see what's going on. We know that this is to the 5th. That's why it does all those little squiggles. We're just kind of zoomed out far to not be able to see what's going on. And then tangent line and normal line. And it does look like the tangent and normal line are going to be perpendicular. So yeah, I'd say it works. All right. Next, turn the page. On the back now, gotta turn my page on my notes. All right, so we're not gonna do this one, we're gonna skip it because it's the same thing pretty much, just a different problem. All right, here is the meat and potatoes of today's lesson, the product rule. Okay, it says if f and g are two differentiable functions, then d dx of f of x times g of x equals f of x times g prime of x plus g of x times f prime of x. So the original f function times the derivative of g plus the original g function times the derivative of f. Okay. So remember, product means that we're multiplying something. So we know that to use the product rule, we have to use it when we see that we could break apart two functions in one, pretty much. And I'll show you what I mean by that. So it says that the first times the derivative of the second plus the second times the derivative of the first. This is like what you hear a lot or read a lot when if you were to look up product rule, you're going to see a statement very similar to this. Okay, the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, isn't it funny how that works out? And mathematicians had to find a lot of patterns where that kept happening in order to make a rule out of it. All right, example 4. Find f prime of x if f of x equals x squared plus 1 times x cubed plus 3. So what we have here is I have a function, x squared plus 1. We'll call this one our first function. And it's being multiplied with the second function, x cubed plus 3. So these are two separate functions. I could break this apart as two separate functions, and we need to find the derivative of it, okay? So let's find the derivative. So first of all, I'm going to need f prime of x because we're finding the derivative of f of x. Now, for the rule, I need the original function, so that's the first one, so x squared plus 1, times the derivative of the second. So the derivative of x cubed plus 3 is 3x squared. The constant goes away. The derivative of a constant is 0. Plus the second, right? The second one is x cubed plus 3, the one that we haven't taken a derivative of yet, times the derivative of the first one, so 2x. Okay, and we're going to multiply that. So let's see what we get. We're going to get x squared times 3x squared is 3x to the 4th, plus 1 times 3x squared is 3x squared, plus 2x times x cubed is a 2x to the 4th, and then 2x times 3 is a 6x. Okay. We have like terms right here and right here. So this is going to equal 3 plus 2 is 5. So 5x to the 4th plus 3x squared plus 6x. And this is the derivative of f. It literally took me 2 lines of work. The only other way to do that is using power rule. But to use power rule, we'd have to FOIL that out and then use power rule. And this method is way, way, way quicker than having to do that because we don't want to multiply that out. We want to just do it as it is. Okay, so it's a nice rule to have. It's a nice shortcut. Another shortcut to add to the list. All right, example 5, it says to find the derivative of h of x, verify your results by multiplying the two binomials and using the power rule, what I just said. So this time we're going to verify using the power rule. And you're going to see how much longer it takes to use the power rule versus our new product rule. Okay, so let's label this one product rule. Okay, and I'll just color code these. We'll let this one be my first one, and this one is my second function. Okay. So let's find the derivative of h of x. So I'm going to have the first function, 3x minus 2x squared, times the derivative of the second. So the derivative of 5 plus 4x, well, the derivative of 5 is 0. The derivative of 4x is a 4, so times 4, plus the second, so 5 plus 4x, times the derivative of the first. So the derivative of the first would be 3 minus 4x. And then we just have to multiply that out. So 4 times 3x is 12x. 4 times negative 2x squared is negative 8x squared. Plus, this one we have to FOIL out. 5 times 3 is 15. 5 times negative 4x is negative 20x. 4x times 3 is 12x. 4x times negative 4x is negative 16x squared. All right, and let's get our final answer here. So the highest degree is the squared. So we have like terms right here. Negative 8x squared and negative 16x squared. That's what, negative 24x squared. And then we have x's. We have a 12x, a negative 20x, and another 12x. Let's combine the 12s. These are both positive. So 12 and 12 is 24. And then 24 minus 20 is just 4. So plus 4x. And then the constant plus 15. So h prime of x equals this. Okay. So that was using the product rule. So now let's try it out with the power rule. So we first have to multiply first. So multiply, and then we're going to use the power rule. Okay, so we got to multiply this out. So I have h of x equals, so 3x times 5 is 15x. 3x times 4x is a 12x squared. 2x squared, negative 2x squared times 5 is negative 10x squared. And negative 2x squared times 4x is negative 8x cubed. So putting this in standard form, I'll have negative 8x cubed. I have a 12x squared minus a 10x squared. Those are like terms, so that would be plus 2x squared, and then plus 15x. Okay, now I am ready to apply the power rule. So h prime of x equals negative 8, well, 3 times negative 8 is negative 24x squared, plus this one would be 4x plus 15. And we better get the same thing, and we did. Okay, so as far as work goes, it's about the same. It might take you longer to multiply something out. So, I mean, choice is up to you. If it says to use product rule, but you would rather use power rule, you can totally do that. But there will be problems where it will make it way, way, way more difficult to multiply. So make sure you choose wisely, but the choice is up to you. Okay. Challenge questions, true or false? Okay. If f prime of x equals g prime of x, so if the derivative of f equals the derivative of g, then f of x equals g of x. Well, is that true? If their derivatives are equal, does that mean that the functions were equal? Well, the answer is false. And if you're wondering why, it's because, well, we don't know what the constant was. The constant could have been 15 on one, or it could have been 1,000,000 on the other. So we don't know because the derivative of a constant is 0. So the constants could be different. And since we don't know that, we can't assume. So it's false, and we have to give a reason why. Constants could be different. Just going to put diff for different. And then we have to give a counterexample. Example, what if we have f of x equals 3x squared plus 4, and g of x equals 3x squared minus 24? Their derivatives are both going to be a 6x, but each of them have a different constant. So this one crosses the y-axis at 4, and this one crosses the y-axis at negative 24. So they're not the same function by any means. Okay, so we can't always assume that. All right, sorry, the papers got messed up. Number 2 says if f of x equals g of x plus a constant, then f prime of x equals g prime of x. Yeah, if f of x equals g of x plus whatever constant g of x is going to have, Yeah, the derivative of a constant is going to be 0. So if that's all that's different between them, it doesn't matter. Their derivatives will be the same. So this is true. And we'll put for your notes, constant won't matter. Sorry, you guys can't see. Its slope, or aka derivative, will always be 0. All right, turn the page. Last page, and this one doesn't have a back to it. All right, number 3. Remember, we're still on the true or false. If y equals pi squared, then dy dx equals 2 pi. Well, if pi was a actual variable, then yeah, that would be true. But it's not. It's false. Because pi is a number. Pi is 3.14159. It has a it has a decimal that goes off to infinity that has no pattern. So we treat pi like a variable a lot of the time, but pi is not a variable. It's not an unknown. We know exactly what pi is. Pi isn't a variable. So we do not use power rule on pi. Pi we treat as a constant. It's a constant. Hold on a second. Lucas, you have IXLs to be doing. Get off YouTube right now. Sorry about that, guys. All right, number 4, true or false? If y equals x over pi, then dy dx equals 1 over pi. Okay, we just figured out that pi is a variable, okay? So we have x over pi. Well, when we take the derivative of x, it's just a 1. So all we'll have left is 1 over pi. That's true. True, true, true. So we can say y equals x to the first over pi. So y prime will equal 1 times x to the 0, because we have to subtract it, make it go down a degree. We're just showing all the steps to show why it's true. So y prime equals 1 over pi. Lucas, computer, back over here at your desk. Get off of YouTube right now. Sorry again. I learned that when my son says okay, he just says it to appease me, and it does not mean that he agrees or that he's going to do what I ask. That's what I've learned. Right. Anyways, application problems. Example 6. Use the position function s of t, where v naught, anytime you see a v sub 0, that just means v naught, is the initial velocity, and s naught is the initial height of the object. Okay, so we have v naught is the initial velocity, and we have s naught is the initial height of the object. Okay. All right. A silver dollar is dropped from the top of the Empire State Building, which is 1,362 feet tall. Determine the position and velocity, which is the instantaneous rate of change, functions. Okay. Instantaneous rate of change means we're taking a derivative. Remember, velocity equals slope. Oh, you guys can't see, sorry. Okay, so let's start with number 1, numero uno. Okay, so we need to determine the position and velocity functions. Okay, so position has to do with this formula, and we have an initial velocity and an initial height that we need to fill in. Okay, well, v naught, the initial velocity, well, it's the velocity of the silver dollar that we're dropping, but before we drop it, it's in our hands. So its initial velocity, its v naught, is going to be 0. It's not moving yet. That's what it's starting off with, no movement. The S naught, sorry, I got a phone call. S naught is the initial height of the object, and the height that it's starting off with is that 1,362 feet, because that's how tall we are up on the Empire State Building before we drop this coin. So 1362. Okay, so we know what we can plug in now. So for our position function, S of t, it's going to be negative 16 t squared. And then since the v naught is 0, 0 times t is 0, wipes that term out. And it says the average velocity. So we're going to be finding the slope. We're going to use slope formula to find an average velocity. But because it says velocity, okay, so number 2, we're determining the average velocity, the rate of change on the interval from 1 to 2. So average velocity means that we're going to be using the slope formula because we're going to take an average between slopes on this interval. So we're going to come up with 2 points here. So the first one, we got to figure out where x is 1. What's the y value? So we need to plug it into the original equation to find that y value. So let's see, if I plug in a 1, that would be negative 16. Negative 16 plus 1362 is 1346. Okay, and now let's find when x is 2. What is it? Okay, well, negative 16 times 2 squared. 2 squared is 4. Negative 16 times 4 is negative 64 plus 1362, and I get 1298. Anytime you're finding y values, you always go back to the original equation. Okay, so we need delta y, the change in y over the change in x, and we're going to use the slope formula. So y2 minus y1, 1298 minus 1346 over x2 minus x1, 2 minus 1. So we're going to have, let's see, 1298 minus 1346 is negative 48. It's negative because it's falling. Okay, so it's got a negative slope. So negative 48 over 1 means that this is falling at a rate of negative 48. What are the units? Initial velocity, feet, and I don't know if it's minutes or seconds, but I'm assuming it's going to be seconds. So we'll say feet per second. Because usually when we're seeing how something falls and it's in feet, we want to know how fast it's going. So negative 48 feet per second, because gravity's going to pull it down really quick. So we need to go, it's not going to take minutes, it's going to be seconds. Okay, so that's number 2. Number 3 says to find the instantaneous velocities when t equals 1 and t equals 2. Okay, that means we need to use the velocity function, v of t, and we need to plug in a 1 and plug in a 2. So start with v of 1, and that would be negative 32 times 1. So the velocity at the time equals 1 is negative 32 feet per second. And then at v of 2, that's negative 32 times 2, using the velocity function right there. Negative 32 times 2 is negative 64 feet per second. Since these are both part of the answer, I'm just going to box them. Okay, that was number 3. Number 4, let's see, it says find the time required for the coin to reach the ground. When the coin reaches the ground, that means the height now is 0. So ground 0, right? Ground 0, and then the Empire State Building is 1362 feet up in the air. Okay, so when it hits the ground, that means the height now is 0. It's hit the 0, okay? So that means we need to take the position function, and we need to set it equal to 0 and figure out what time will that be when it strikes the ground. So 0 equals negative 16t squared plus 1362. And we're going to solve. So since the only variable I have is the t squared, we can totally isolate that. So we're going to need to subtract 1362 from both sides. So I'll have negative 1362 equals negative 16t squared. Divide both sides by negative 16. So we know a negative divided by negative is positive. So this will be, ends up being positive 85.125 exactly. I don't even need to round. That's exactly what it is in my calculator. Equals t squared. And then we have to take a square root. Now, yes, we are solving for a variable and we're taking a square root. And so we would get a positive value and a negative value, but time doesn't make sense to be negative. So we only care about the positive version. So the square root of 85.125 is 9.226. So 9.226 seconds when it hits the ground. So like I said, it's not going to take minutes. It's going to take a matter of seconds for that coin to hit the ground. All right, number 5, it says find the velocity of the dollar just before it hits the ground. So now we know the time that it's going to take to hit the ground. So let's use the velocity formula, v of t. Actually, we know the t value is going to be 9.226. We're going to plug that in. So negative 32 times 9.226. Negative 32 times 9.226 is, actually it's exactly negative 295.232 feet per second. So it's traveling really fast. It is falling 295 feet per second. That's a lot of feet per second that it's falling. And you have to think of gravity too. When it starts off, it starts kind of slow, and then gravity's pulling it harder, harder, and harder as it's falling closer and closer to the ground. So as it gets towards the ground, the closer it gets, the faster it is moving. Okay. Letter B. A projectile is shot upward from the surface of the Earth with an initial velocity of 120 meters per second. So we know that it has been shot upward from the surface of the Earth, so from the ground, and it has an initial velocity of 120 meters. So we have a v naught. Oops, guys can't see. All right. And it says, what is the velocity after 5 seconds? And then after 10 seconds? Okay, let's find it. So we have to use our position function. The position function was given up here. And so we'll have s of t equals negative 16t squared. We have an initial velocity of 120. So when I plug it in up here, it'll be 120t plus the initial height. This is our s naught. So if the initial height is from the surface of the Earth, that means the initial height is 0. So plus 0. Okay. What is the velocity? Well, since we're finding velocity, that means we need to take a derivative so that we can have the velocity function, because velocity means slope. All right, so to get that, we need velocity. That's going to equal s prime of t, which is going to equal our v of t function. All right, this is just a formality for your notes. You can just go straight to v of t once you understand, oh yeah, velocity is just the derivative of the position. Okay, so the derivative is negative 32t plus 120. So there's our derivative function. Okay, so now let's find the velocity after 5 seconds. After 5 seconds. So v of 5 equals negative 32 times 5 plus 120. Negative 32 times 5, so my calculator is negative 160. Negative 160 plus 120 is negative 40. And what are we in? Meters and seconds, so meters per second. Okay. All right, well, what is it after 10 seconds? How fast is it going then? And before I start plugging in the 10, I want to mention it's negative because a projectile was shot up into the air and now it's falling down. So that this is a time where it is falling. Okay, so at 5 seconds, it's already falling towards the ground. After 10 seconds, v of 10, we'll have negative 32 times 10 plus 120. Well, negative 32 times 10 is negative 320. Negative 320 plus 120 is negative 200 meters per second. So now it is falling even quicker at 10 seconds. Look at that. Look at that difference. Ooh, it's catching that gravity. This is where gravity could be your friend or it could not be your friend, especially if you're the one falling. All right, so that's it. And then your homework will be on Google Classroom. Have a good one, you guys.